Okay, let's look at this trolley system shown here connected to a fixed pulley, and there is another block of mass small m which is hanging by the rope. The rope is massless, let's assume, which is pulling this whole trolley towards the right, and the system is accelerating in this direction with acceleration a. Let's call the mass of this trolley capital M. We need to find the acceleration a. How do we solve this? This can be done with the help of something called free body diagrams. And after drawing the free body diagrams, we can form equations to solve it. Free body diagrams are nothing but we isolate the components of the system and then draw all the forces acting on the system and find the net force and equate it to m times a. See, we know by Newton's second law that F equals ma. M and A can be seen in this system as capital M times A is how this big block is moving, and the small block is moving downward with MA. So if we can find out what is the net force, net external force acting on the blocks by isolating them as free bodies, then we can form equations, multiple equations to solve and find A and the tension in the rope, etc. So this is what we are going to use. Let's consider small block first, and before that let's mark all the forces in the overall system. So this is moving down with an acceleration a. Let's consider downward direction as positive, down is positive, so up is negative for our convention. Right is positive here, and this direction is negative direction. This is for the equations, it will be useful when we write them. And then on the rope there is a tension is pulling it, so tension is a pulling force, so it pulls the block. Here its tension is this way, tension is acting this way, and the wheels are in contact with the surface here of the trolley, so there is a friction, but this is a kinetic friction because it's already rolling and moving forward with acceleration, so we call it F sub k, which is kinetic friction. Now let's take the small block M and try to draw the forces acting on it so that we can come up with the net external force acting on it. There is a G acting downward, so there is mg in this direction, and then there is tension pulling it up, so T is upward. So using this we can say that, and the object is also accelerating downward with ma. So let's first write this side of the F equal to ma equation. Here in this case it's ma, and on the left hand side let's put all the forces with the corresponding signs because of their directions. So down is positive, we said, so mg is positive. Then T is upward, upward is negative for us, so it's minus T. So this gives us equation 1. Then let's look at the bigger block, capital M mass. So here what are the forces acting? We can see that kinetic friction, this force due to that is acting in this direction, and the tension from the rope is pulling it in the right hand towards the right hand side, and we know that tension direction we have taken it as positive. So let's write the ma part of the equation first, which is capital M times acceleration is the same a, is equation 2. On the left side let's put in all the forces. The forces, we know T is positive direction, so T, and Fk is negative direction, so T minus F sub k is ma. So these are the two equations which we can solve. Simply if we add equation 1 and 2, the T's will cancel out, we get mg minus Fk is ma plus ma and all that. So we can find out the acceleration and tension if we are given this mass, the small mass, and the coefficient of kinetic friction. If we are given the coefficient of kinetic friction, that times the normal force can be plugged in place of Fk. So if we are given these three, the mass of the two blocks and the coefficient of kinetic friction, we can plug it into these two equations and we can solve for acceleration of the body or the system downward. Thank you.